Section 4.4, we're going to talk about obversion now. And if you're going to do obversion, remember we had conversion, which was a one-step operation to obvert categorical propositions. You remember you start with the A, E, I, and O. To obvert those takes 2 steps, okay? And they're not that hard. First of all, you look at the categorical proposition and you're going to change the quality. Affirmative to negative, or if it's a negative, you change it to affirmative. That's what quality is about. Affirmative, negative, negative, affirmative. And so here's how you would do this. If you have an A or an E proposition, if it's an E, no is going to switch to all, and all is going to switch to no for A and E. Okay, so this will become clear. So if you have all S or P to change the quality, you would say no S or P. If you have an I or an O categorical proposition, you remember this has the word some in it, the way you change the quality on those is by R and R naught. If something's R, you change it to R naught. If something is an R naught, you change it to R, okay? And that will swap or switch back and forth from affirmative to negative. Okay, the second step, so that's the first step right here. Change the quality. Then you replace the predicate term with its term complement, and I need to explain what the term complement is, okay? First of all, what is the class complement? It's real easy. The complement of a class is the group consisting of everything outside the class. So if you have the class of dogs, okay, there's dogs right there. The class complement is everything outside that class, okay? It's the class of non-dogs. So if your class is dogs, the class complement is non-dogs. And so the term complement is the term you use to designate that class complement. And often, if you have the class dogs and the class complement is non-dogs, often your term is going to be non-dogs. But the reason they call it the term complement is, let's say you have a class complement of physicians who don't have their licenses revoked. Okay, that's a class complement of some previous class. You know, physicians who don't have their licenses revoked. You may want to have a pithier term, and so even though you have a class complement, you may make the term complement something like licensed physicians. But often, if your class complement is a certain term, often your term complement will be the same, but they still distinguish it because sometimes your term complement can be a shorter, pithier phrase, okay? Licensed physicians for the term complement of the class complement, doctors whose licenses haven't been revoked. You see, the term complement makes more sense. But for our purposes, if you have the class P, the term complement is going to be non-P. Okay, so with that said, you're going to understand a little bit better that when you have a categorical proposition, all S are P, P is the predicate, the term for the predicate class, you would replace that term with the term complement. It would be all S are non-P, okay? So those are the 2 stages. Change the quality and then replace the predicate with its term complement. Okay, with that said, let's go down and look at each of the 4 categorical propositions. Now there's some good news here. All 4 categorical propositions are logically equivalent to each other, okay? A, E, I, and O, when you obvert them, the meaning is preserved, okay? So, if you use an English proposition and you obvert it, if it's true to begin with, it's going to be true after you obvert it for A, E, I, and O. So it's real simple. And the Venn diagrams, you should be able to guess this, they're going to be exactly the same. So you obvert the statement, draw a Venn diagram, it matches exactly what the Venn diagram was for the ordinary categorical propositions. So let's just start out with A propositions. Okay. All S are P. So change the quality, all turns to no, so it becomes no S. And remember, you replace the predicate with its term complement. So you would say no S, R, non-P, and because we have these non-Ps going on here, you may want to do something like this. No S, and always with the copula, why don't you go ahead and put a parenthesis around that, and then you write the non-P here, just to help you not get confused, okay? So if we had like an English sentence, and remember, all S or P is equal to no S or non-P. This is an immediate inference. It actually can be written. It is essentially a valid argument. If all dogs are animals, therefore no dogs are non-animals. So all dogs are animals. That's true, right? All dogs are animals. Therefore, no dogs are non-animals. That's true. Okay? And let's go ahead. Why don't we do the Venn diagram for this one? The Venn diagram should be the same. So if we had over here all S, R, P, we're going to obvert it, so it would be no. All changes to no. No S, R, and put parentheses, non-P, right? So this right here is for the A categorical proposition. Okay, all S or P, you know that. It means every single S is going to be in the overlap region. That means you're never going to have an S that's not a P, and that's why this is empty, right? Okay, over here, we obverted no S or non-P, and non-P means outside the P circle. Anytime you get a non-something, it means outside that class, not subject class. So what this is really saying, I'm going to write this down here. If we were going to write this in English, it really means this. No member of S is going to be found outside the P circle. The P circle, okay? And this sentence, I recommend that you use them. Use this kind of sentence. It's going to be very helpful. Really what this is saying is you are not going to find one member of S that is outside the P circle. Non-P means outside. So you're not going to find a member of S that's going to be outside this P circle. So here's S. It's going to be here. It's not going to be here. So we will shade this as empty. And you can see the Venn diagrams are the same. Okay? Now this little wordy sentence I wrote, very, very important. I want you to understand conceptually how that works. Okay, let's go back to the first page again. And let's do the E statement. Okay? Okay, E, this is equivalent. No S or P. If we're going to obvert this, no changes to all, and we replace the predicate with its term complement. So it's going to be all S are non-P. We'll put a parenthesis around this here. Okay? So if you had no dogs or reptiles, is that true? Yes. Therefore, all dogs are non-reptiles. If not, dogs aren't reptiles. Therefore, every single dog, guess what? It's a non-reptilian organism. Okay, true, true. So with this, we should see the same Venn diagram. So if we're going to come down, let's go down 2 here. Let's do the E here. So we have no S, R, P. We're going to obvert it, so no changes to all. All S, R, let's do a parenthesis there, non-P, okay? And then let's write a pithy sentence up here before we draw it. This really says this: every member of S is going to be found, okay, outside the P circle. Okay, so let's read this here. Every member of S is going to be outside the P circle. So here's S, and it's saying every member of S is going to be outside the P circle. So if this is all S, it's not going to be here. So this is going to be empty. And what that conveys is if it's an S, it's outside of the P circle, and here's the P circle border, right, coming around. So every S is going to be around here. That means this is going to be empty. So when you read all S or non-P, say to yourself, every single member of S is outside the P circle. So S is going to be here, outside the P circle, therefore this is empty, and that's exactly what this diagram is. And up, up above with A, that's what it was, so these are equivalent also. Venn diagrams match, they match up here. So far, so good. Okay, let's go to the I statement. Okay, so here's I down here. Some SRP, and you're going to obvert this, so you need to change the quality. Remember, with the I and the O, R goes to R naught. If this is affirmative, to make it negative, you're going to say some S are not non-P. Okay? And the non-P is you change the predicate term with the term complement. So that's how you'd obvert that. Now, here's an English sentence. Some trees are maples. Is that true? Yes, it's true. Some trees are not non-maples. So if you're saying there are at least certain trees, there's at least one tree that is a maple, that means you're going to have some trees out there. And when you look at that tree, you're going to say not non-maple because it's a maple. So some trees are not non-maples. That's true too. So that's an argument. Let's go back to the Venn diagram for this. And let's erase what we've done so far here. Okay, so we're going to erase this stuff here. We'll start up here. Okay, let's go and get that out of the way there. Okay, let's come back up. Here's the I statement. Okay, and the I is some S R P. We're going to obvert it. Change the quality. Some S are not, and replace that predicate term with its term complement, non-P. Then let's go up and please do this sentence. It does help, okay? So this is saying there is at least one S. There is at least one S that is not going to be found outside the P circle. Okay? So there is at least one S that is not outside the P circle. Non-P means outside the P circle. So here's S. You have at least one that's not going to be outside the P circle. That would mean to be somewhere around here, right? That means you have an S in here. There's at least one that isn't outside the P circle, means S and P have to overlap. And the I here, some S R P, that's there. We already knew that. So they're equivalent. Okay, we go back to one more. Let's do the O now. Okay, some S are not P. To obvert that, change the quality. Some S are non-P. There's the predicate term. Replace it with the complement term, right? All right, so some trees are not maples. That's true. Therefore, some trees are non-maples. That is true. So let's go and do the Venn diagram for this one. Okay, let's go here and we'll erase this stuff here. And we'll do the O right here. So we got the O proposition. Write this out. Some S are not P, right? And that would be right here. There's at least one S that is outside the P circle, right? And if we obvert that, some S are, we're changing the quality, non-P. Okay? Now, you know, I guess this is one thing I wasn't mentioning. This is still the S class. This is still the P class. This is still the S class. This is still the P. You don't make this non-P. You keep those the same. Okay? So, if we were going to write an English sentence up here, right there, we would do something like this. There is at least one S that is outside the P circle. Okay? There is at least one S that is outside the P circle. Okay? And just look how this reads. Some S, there is at least one S that is, R that is, and then non-P is outside the P circle. So you come here, there's at least one S that is outside the P circle. It's not going to be there. If it's S and it's outside that circle, you're going to put an X there, and then that's going to be true. And if we go up, I failed to do this before, but I think you guys are figuring this out. This is the S class. Oops. So this is S. This is P. This is still S. This is still P. And another, I'll say it again. Just because this is non-P, you don't make this non-P. This is still P. That's all you need. They don't change. Non-P just means outside that P circle. Okay, that's Obversion. You understand through the English propositions and the Venn diagrams that the meaning is preserved. The Venn diagrams are all the same. All four obverted categorical propositions are equivalent. Okay, the next thing we'll go on to is contraposition.